Alright, so these are the answers to the problems for x and y. And these two are fairly straightforward. This one here, we could use the fact that these are two parallel lines and we have it cut by a transversal. So that means that 2x is congruent to 30, right? So we can set those equal to each other. And then we could also set x plus y equal to 24 and substitute in our value for x and solve for y, right? Because these two are also alternate interior angles. And we can get our answers. Over here for number 4, it's a little bit tricky, but if you have a shape that looks like this, a quadrilateral, and you have two angles that are congruent in the quadrilateral, then they must be right angles. Okay, so right, so then that means that if one angle is a right angle, then that means all the angles are a right angle. So then we could set 6y equal to 90 and 3x equal to 90 to find our values for x and y. Okay, so let's go ahead and move on to the next page. And here we have parallelograms on a coordinate plane. And so you can use the distance formula, the slope formula, and the midpoint formulas to prove that quadrilaterals are parallelograms by either showing that opposite sides are congruent using distance formula, or by showing that the diagonals bisect each other. So we could use midpoint formula to find the center point of one diagonal, and then we could use midpoint formula to find the center point of the second diagonal. And if they are both the same point, they're in the middle, then that means that the diagonals bisect each other, and we could prove that the quadrilateral is a parallelogram. And then lastly, we can go ahead and use slope formula. So we can prove that two sides have the same slope, which means they're parallel. And then we can also prove using distance formula that those same sides are congruent, and in which case we will have been able to prove that the quadrilateral is a parallelogram using theorem 6.12. Alright, so let's go ahead and try that over here. So method 1, here we have the quadrilateral KLMN, and let's go ahead and graph it to start out. So we got K is at 2, 3, 1, 2, 1, 2, 3. This is K. L is 8, 4. So 3, 4, 5, 6, 7, 8. And 4 is up here. That is L. And then 7, negative 2 is 7. Negative 2 is here. And that is M. And then 1, negative 3 is down here. And that's going to be N. And we have K. So I'm going to draw my shape like so. Okay, so now we're using midpoint formula. So we need to figure out the midpoint between N and L, and we need to figure out the midpoint between K and M, and if they are both the same point, then we've proved that the shape is a parallelogram. Okay, so let's say the midpoint of NL is going to equal to N is here and L is there, so it's going to be 1 plus 8 over 2. And then we have Y, negative 3 plus 4. Negative 3 plus 4 over 2. So then we're going to simplify that, of course, and this is going to be 9 over 2. So it's going to equal to 4 and 1/2 over 1/2. Okay, so then we're going to find the midpoint between K and M. So here's K and M, and so that's going to equal to K and M. So we got 2 plus 7 over 2. And then we have 3 plus negative 2. So 3 minus 2 over 2. So then that's going to equal or simplify down to 9 over 2, or 4 and 1/2. So I'm going to put here 4 and 1/2 and 1 over 2. Yeah, anyhow, this is a 4.5 and 1 over 2. So they are a parallelogram. So I'm going to go ahead and say KLMN is a parallelogram. Okay, now here's method 2 is using the distance formula. So how are we going to do that? Well, we're going to show that KL is congruent with NM, and that KN is congruent with LN, and that one would use theorem 6.9 to prove that it's a parallelogram. So let's see if I can finish all that work in here. So this is going to be the distance of KL is going to equal to the square root of K and L. Okay, so x2 is 8 minus 2 squared plus 4 minus 3 squared. So that's going to equal the square root of 6 squared plus 1 squared, which is equal to square root of 36 plus 1, so square root 37. Whoa, 37. Okay, and then we need to show that KL is congruent with MN or equal to MN. So I'm going to do MN is equal to the square root of M and N and M. So let's do 7 minus 1 squared plus negative 2 minus a negative 3, so it's plus 3 squared. And so that's going to equal to square root of 6 squared plus 1 squared, which is going to equal square root 37 as well. So we've shown that KL is congruent with NM, and now we need to do KN is congruent with LM. So KN is going to equal to the square root of KN. Oh, wow. So let's do 2 minus 1 squared plus negative 3. Oh, I'm sorry. 3 plus 3 plus 3 squared. So that's going to equal the square root of 1 squared plus 6 squared, square root of 37 as well. Okay, so looks like all the sides are congruent. Let's go ahead and check the last one. This is going to be LM is equal to the square root of L and M. Okay, so we have 7 minus 8 squared plus negative 2 minus 4 squared. So that's going to equal to negative 1 squared plus negative 6 squared. So it's going to be 36. So that's equal to square root 37. So we've shown that the opposite sides are the same length, and so the shape is a parallelogram via the distance formula method or the slope formula method. And of course you're going to want to do the slope formula method because it's shorter, but you're going to be asked to perform this second method on the assessments, so be able to perform both. And let's go ahead and complete the other problems here, all the rest of these here.